Okay, tonight's lesson are on inscribed angles. Inscribed angles are created when two chords intersect at a vertex point that is on the circle. And that creates two inscribed angles. Quickly, let's go through the review. You're going to write noun or verb to the word intercept, the way it's used in a sentence. Defense tries to intercept a touchdown pass. That's a verb. The y-intercept of a line is the y value at x equals 0. That's a noun. Cryptographers intercept and decipher code messages, verb. And the x-intercept of a line is the x value at y equals 0, noun. A vocabulary word is, again, the inscribed, word inscribed. An inscribed angle is formed by two chords with a vertex on the circle. So the vertex is on the circle, and that's how the angle is created. So let's quickly review that. Write circumscribed or inscribed to describe each angle. So angle 5 is inscribed, it's inside the circle. Angle 6 is circumscribed, it's outside or around the circle. Angle 7 is also circumscribed. And then the last one, number 8, is inscribed within the circle. Angle ABC with points ABC on a circle is an inscribed angle. An intercepted arc is between the sides of an inscribed angle. So the arc that's created here in this problem, this would be the intercepted arc, is that arc between the inscribed angle. The inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So I get the measure of arc AC by, remember, I have the central angle here, and it's an angle that runs out like so. And that gives me a measure of the angle AC. Measure of angle B, the inscribed angle, is 1/2 of that measure. So suppose AC equals 90. I don't know what it is, but suppose it equals 90. Then 1/2 of 90, 45, would be the measure of angle B. Likewise, if the measure of angle B is 60, then twice that would be the measure of the arc AC, so the arc would be 120. So let's use the inscribed angle theorem. In circle O, what is the measure of angle A? We're going to complete the reasoning model below. I know the sides of angle A are chords, and the vertex is on circle O. So here's the vertex of that angle. Angle A is an inscribed angle. I can use the inscribed angle theorem. Now that looks like a diameter to me, which is the hypotenuse of this triangle. And I say hypotenuse because if that's a diameter, that means it's a semicircle, and that the total measure of semicircle is 180, and 1/2 of 180 is, of course, 90, which makes this a right triangle. So it's definitely, the diameter is the hypotenuse of that of the circle of that right triangle. So let's look at a few other problems. In circle P, I know that MS, I'm making up stuff. The measure of SV is 120. So the measure of this arc right here is 120. I know that the measure of angle RPS, this angle right here, is 76. Now, RP and SP are both radii of the circle, so therefore they have the same measure, which means this is a isosceles triangle. So I can do 180 minus 76 and get 104, divide that by 2, and I know that both of these angles PRS and angle PSR, have a measure of 52. So problem number 3, what is the measure of angle PRS? That's going to be, clear this up here, 52. Now, looking at the measure of RSV, this is RSV here. I know that the measure of SV is 120. I know that the measure of RS now, I know that to be 76, because if this angle here, this is the central angle created between R and S, it's 76. So the measure of RSV is going to be 120 plus 76, or 196. RT, the segment RT is congruent with the segment SV. So they're congruent chords. So congruent chords have congruent arcs. So the measure of arc ART is going to be 120, just like the measure of arc SV. And finally, RVT, this angle right here, is going to be 1/2 of the measure of RS, or RPS, which is 1/2 of 76, 60. Scratch that, what I just said, because I'm looking at the wrong angles. I'm looking at RVS, and we should be looking at RVT. If the measure of RT is 120, then 1/2 of 120 is, of course, 60. So instead of recording this thing all over again, just pardon my mistake. So I was looking at RVS when I should have been looking at RVT. So 1/2 of RVT, which is 120, is 60. Corollaries to theorem 1211. There are 3 corollaries to corollary 1211. 3 corollaries to theorem 1211, the inscribed angle theorem. First one is 2 inscribed angles that intersect the same arc are congruent. So in my picture, angle A and angle B both intersect the blue arc, so those 2 angles are congruent. Corollary 2, an angle inscribed in a semicircle is a right angle. So we've seen that in the previous example. If I was to draw the diameter here, it would be the hypotenuse of the right triangle. And finally, corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So angle A is supplementary to angle C, and angle D is supplementary to angle B. So for 14 through 18, we're going to write true or false using the diagram at the right. Angle P and angle Q intercept the same angle. That's true. They're both 90-degree angles. Angle SRP and angle Q intersect the same angles. That is false. They do not intersect the same angles. Arc TSR is a semicircle. That's true. We can tell that the center of the circle O and TSR, and the diameter goes, TOR is the diameter of the circle. Angle PTS and angle SQ or SRQ are opposite angles. So we're looking at PTS and SRQ. That's false. Those aren't even in the same quadrilateral. And finally, angle PTS and SRP are supplementary angles. That is true. All right, so let's continue on. Using corollaries to find angle measures. In the diagram at the right, what is the measure of each numbered angle? We're going to find 1, 2, 3, and 4. Use justifications at the right to complete each statement. So, measure of angle 4 equals 1/2 of 60 plus 80, because this arc here is 140, 60 plus 80. So we're going to add those together. So the measure of angle 4 is 70 degrees. Circle the corollary you can use to find angle 2. An angle inscribed in a circle, semicircle is a right angle. I don't see that being the case. The opposite angles of a quadrilateral inscribed in a circle are supplementary. That I do see. So that's our answer. So we're going to solve for the measure of angle 2. Measure of angle 2. So measure of angle 4 plus measure of angle 2 equals 180. 70 plus measure of angle 2 equals 180. Subtract 70 from both sides, and we get that the measure of angle 2 is 110. Now let's underline the correct word to complete the sentence. The dashed line is the diameter. Circle a corollary you can use to find the measure of angle 1 and 3. And that's an angle inscribed in a semicircle is a right angle. In this case, though, since they are both opposite angles, you probably could pull that one off too. Measure of angle 1 is 90 degrees. Measure of angle 3 is 90 degrees. So 1 is 90, 2 is 110, 3 is 90, and 4 is 70. And it's quadrilateral, so if we add all this together, we better get 360. All right. Theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intersected arc. So I have angle BC, or angle C here. It intersects BDC, and so its measure is 1/2 of what BDC is. Now look at this. This intersects the arc going this way, the minor arc, where this one intersects the major arc. So we have to pay attention to that. So suppose the measure of angle C is 50. What is the measure of arc BDC? Well, it's going to be twice the measure of angle C, or 100. Suppose the measure of arc BDC is 80. Well, the measure of angle C will be 1/2 of that measure, and it would be 40. Now let's look at this diagram at the right. We have a tangent and a diameter. So the measure of ADB equals 180, because this is a semicircle. So the measure of angle ABC is 1/2 180, or 90 degrees. So that's how you use theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. All right, finally, finding arc measure, problem 3. In the diagram at the right, KJ is a tangent to circle O. What are the values of X and Y? We're going to circle the arc intercepted by JQL, and as you can see, that's already shown. It's arc JL. And underline the arc intercepted by KJL. Underline the arc, JQL, so JQL. I think I did something wrong there. All right, let's try that again. Circle the arc intercepted by JQL. That's going to be JL, correct. Underline the arc intercepted by KJL, and that again is also the same arc, so we should underline that. By the inscribed angle theorem, the measure of JL equals twice 35, because here's my measure, 35, and so it equals 70. By theorem 1212, X equals 1/2. We're looking for this distance right here. So this is an angle, boom. Here's a chord, here's a tangent. It's 1/2 the measure of JL, which is 35. So the value is 17.5. QL is the diameter, so QJL is a right angle. All right, when two angles intersect the diameter, they create a right angle. So I know by the triangle angle sum theorem that all my angles together of a triangle equal 180. I know that QJL equals 90 degrees and LQJ equals 35 degrees. It's given to me. And all that equals 180. So I'm going to add those together. 125 equals 180. Subtract 125 from both sides, and I get Y equals 55. So that's how you find arc measure using the different theorems that we just learned. So let's see if we understand what we learned tonight. It's a lot. A classmate says that measure of angle A equals 90. What is your classmate's error? Is diameter AC a side of angle A? Yes. Is angle A inscribed in a semicircle? No. So there's the error your classmate made. The error is thinking that the angle with a diameter as a side intercepts a semicircle. It does not. Now, angle ABC, if I was to draw that, would be a right angle because that does intercept a semicircle. So the measure of angle A is not equal to 1/2 of 180. All right, that's your lesson for tonight. We'll come in and work on some worksheets. We'll go over the homework from 12-2. Make sure everybody's good on that. Make sure you get that done. So tonight you had the 12-2 homework and the notes. We'll come in tomorrow, work on inscribed angles, and then we're going to look at angle measures and segment lengths within circles. I know we're going kind of fast. If you got questions, please do ask in class. I'll see you tomorrow. Have a good night.